Let's have a look at some examples involving exact trigonometric ratios. We're going to start off with some fairly easy, straightforward examples, and then we're going to move on to some pretty interesting expressions. In fact, one question for you. Ever wondered if, say, sine of 15 degrees has an exact ratio that represents it? Or say cos of 15 degrees or tan of 15 degrees? Because it seems like the exact trigonometric ratios tend to go up in 15-degree increments. So, 30 degrees, 45 degrees, 60 degrees. So there seems to be an exact ratio for those. We even looked at 0 degrees and 90 degrees, but 90 degrees is 30 more than 60. So they seem to be going up in 15-degree sort of steps. Is there a 75 somewhere then before it goes to 90? You'll be maybe pleasantly surprised later on. Let's have a look at some of the more basic examples first. Now, this sine squared 30, okay, when you see a little 2 there, that just means you're just squaring the trigonometric ratio. It's just a shorthand way of sort of involving, sort of raising a trig ratio to a power. So that's just sine, okay, of 30 degrees all squared. Okay, so anytime you see this, it could be a 3, 4, it doesn't matter what it is. It just means raising it to the power of whatever the power indicated here is. So sine of 30 is half. Okay, so hopefully we know that by now. All squared, and that's going to be 1/4. Okay, how would you do this on a calculator? Okay, so if I type in sine of 30, okay, and then press the square button. Okay, you can't put the square sort of after the n. It kind of doesn't work on these model calculators. And press equals, and you'll get 1/4 there as your answer. So it all works out nice. And this also gives us a way of, coming up with the exact ratio if you've forgotten the table. All right? You don't have to necessarily memorize it. Great if you could. We'll speed things up. So let's say sine squared of 45 degrees. I'll get to the point here in this example. That's just 1 on root 2 all squared. And that's just 1 on root 2 multiplied by 1 on root 2. Okay, so 1 on root 2 multiplied by 1 on root 2. And root 2 times root 2 is just 2, so that's going to give us half. Okay, so sine of 45 degrees, if I press equals there, it's 0.707. Let's say you don't know or you've forgotten what the exact ratio was. Square that. You get half. Okay, so that's our answer here. So you know then that sine of 45 itself, so the square root, obviously, of the square of sine of 45, okay, is really the square root of half. And when you take the square root of half, you're taking the square root of the numerator, which is just 1, and then you've got the square root of the denominator, which is just the square root of the denominator, which is root 2. So therefore, the square root of half is 1 on root 2. Okay, and that way you can come up with the exact ratios yourself without having to remember the table. Okay, again, just with practice, I guess you're gonna know these ratios anyway. But just in the interim, if you feel, oh no, I don't know what these ratios are, I've forgotten, I know I've studied them over and over, and I'm, under pressure and I've got a mental blank, this is how you would do that. Let's have a look at sine squared of 60. Now, you and I know that it's root 3 on 2 all squared. Root 3 times root 3, or root 3 all squared is just 3. 2 squared is 4. Again, we could do the same thing on our calculator here. So sine of 60 degrees, okay, we know that it's root 3 on 2, but it's this sort of very sort of random looking decimal. Square it, you get 3/4. And that correlates with our answer here. Root 3 on 2 all squared is 3/4. So therefore, the square root of 3 on 4 is in fact equal to sine of 60. In fact, I'm going to write this here explicitly. So we'll say hence, right, the square root of 3/4, okay, is equal to root 3 on 2, which is equal to sine of 60 degrees without the square. Okay. So again, just a good way of, I guess, or one way of getting yourself out of some trouble there. If you ever forget what the exact ratios are, you can always come up with them. All right, now let's breeze through the next few. Cos squared of 30, well, that's, again, cos squared of 30 is the same as sine squared of 60, isn't it? So I'd expect 3/4 here. Cos squared of 45 is really just the same as sine squared of 45, since sine of 45 and cos of 45 are identical, it's 1 on root 2, right? So I would expect half for that one. Cos squared of 60 is really the same as sine squared of 30, so I would expect 1/4 there. I didn't show the working out for these. It's identical to the first three, except just sort of swap it around because of the complementary relationship between cos and sine. All right, let's move on to tan. All right, so tan squared of 30. We know that tan of 30 is 1 on root 3. Okay, square that, and you get 1 on 3. That's nice. Now, tan squared of 45. Well, tan of 45 is just 1 squared, and that gives us 1. Tan squared of 60. Well, we know that tan of 60 is root 3. Okay, you should be showing all your working out for these questions, by the way. I know I didn't do it for the last one, just to sort of speed things up a little bit, but it is important that you do show all your working out, especially if it's worth 2 marks. Very important. But even if it's not, I would still show working out anyway. Root 3 all squared, and that's equal to 3. Now, by the way, tan of 45 degrees is that's equal to 1. 1 on 1, right? We haven't looked at this yet. No, we will in a subsequent video. But okay, if you took a coordinate plane, okay, and you took the rise over run, for example, if the rise was 1 and the run was 1, you have a right angle triangle. The angle of the line is 45 degrees. And that's very nice. There is a relationship between the tan of an angle and the gradient of a line, okay? But we're not going to worry about that too much at the moment, okay? We'll worry about that later on when we do coordinate geometry in a bit more detail. All right, what about 1 on sine of 30? Well, that's just 1 on 2, okay? So which is 1 divided by half, which is 1 times 2, okay? And you'll get 2. All right, what about 1 on cos of 45 degrees? All right, now a different way I can express this, that's just 1 on root 2 to the power of negative 1, which is just root 2 over 1 to the power of 1, which is square root of 2. Okay, what about this one? Sine squared 30 plus cos squared 30 degrees. All right, now sine squared 30, that's just 1/2, okay, power of 2 plus root 3 on 2 to the power of 2, and we get 1/4 plus 3/4, which is 1. Now, I thought I'd just sort of stop here for a moment, and does it work for any angle? I don't know, let's try some other one. So let's say we did sine squared of 10 degrees, right, plus the cos squared of 10 degrees. Do I also get 1? Oh, you do. All right, what about 1,000 degrees? Interesting. You seem to get 1 every time. That's another interesting result. I won't say much more here. Right. So, moving on to the next set of examples. Okay. Oop, forgot to fill this one in. That's meant to be 30, and that's meant to be 30 there as well. Yep, that's better. All right, 2 sine 30 degrees, cos of 30 degrees. All right, so that's 2 times half times root 3 on 2. Now, 2 times half, that just disappear. Okay, so that really just goes. You're left with root 3 on 2. That's an exact ratio. What's that the exact ratio for? That's either equal to sine of 60 degrees or cos of 30 degrees. Isn't it? And there's a very interesting relationship between this angle here, say for example sine of 60 degrees, and it seems to be half the angle there. Or this 30, if you double it, you get the 60. Another interesting result. Let's have a look at this one. Cos squared 30 degrees minus sine squared 30 degrees. Again, cos squared 30 degrees, root 3 on 2, all squared, minus 1/2, all squared. Okay. And root 3 on 2 is 3/4, minus 1/4, and we end up with 1/2. 1/2, what's that the exact ratio for? Isn't that sine of 30? So that's either equal to sine of 30 degrees or cos of 60 degrees. This is the one that's of some importance. Cos of 60, cos squared of 30, sine squared of 30. Again, there seems to be something going on here. I'm not going to discuss this any further. Suffice to say that there's something interesting going on. Okay. What about this one? So cos 45, cos 30 minus sine of 45, sine of 30 degrees. Again, we'll work it out exactly the same way. Cos of 45, it's just good exercise here, sort of putting your exact ratios to work. So 1 on root 2 multiplied by root 3 on 2 minus 1 on root 2 multiplied by 1/2. Okay, so that's going to be root 3 over 2 root 2 minus 1 over 2 root 2. Okay, and given that the denominators are common, we could just write this as root 3 minus 1 over 2 root 2. If you want to, you could rationalize the denominator. If we multiply top and bottom by root 2, okay, we end up with root 6 minus root 2 over 4. I want you to try something here. I want you to try cos of 75 degrees. And on this calculator here, I'm just going to enter in the the exact ratio that I just came up with there. Okay, so root 6 minus root 2 over 4. Okay, so we've got that. Hopefully I'll just put them both together under the camera. All right, pressing equals, and what do you know? Same result. Well, at least from what we can see here on the calculator, assuming the calculator is not rounding something that's 500 decimal places, but at least on the surface, it appears that there seems to be something going on here as well. In fact, there is, and we're not going to prove it at this point, but this is really the exact ratio for cos of 75 degrees. So this is what I was talking about before. Is there an exact ratio for sine of 15 degrees, sine of 75 degrees, cos of 15 degrees, cos of 75 degrees? In fact, there is. Okay, but we don't worry about this generally until year 11 extension 1. We go into this in a bit of detail. All right, so but just for now, just for the sake of the exercise, I think it was really good to see that. All right, let's move on. Oh, got some more on the back here. All right, so let's try and get through these a little bit quicker. Okay, so we have cos 45, cos of 30 plus sine of 45 degrees, sine of 30 degrees. Okay, and same thing. Okay, same as the last one actually, except instead of the minus, it's a plus, isn't it? So that's going to be 1 on root 2. Okay, multiplied by root 3 on 2 plus 1 on root 2 multiplied by half. Okay, and that's going to be root 3 over 2 root 2. Okay, over 2 root 2 plus 1 over 2 root 2. Okay, and that's just equal to root 3 plus 1 over 2 root 2. Right, common denominator. If you want to rationalize it, you can. You multiply top and bottom by root 2 on root 2. Okay, and we end up with root 6 plus root 2 on 4. Okay, and guess what that is? Right. In fact, I'll just... Right, so there you go. And I might just change that to 15 degrees. There you go. Again, very similar result, if not identical. In fact, they are identical. Again, we're not going to prove the point, but we'll just accept that for the time being. This is really the same as cos of 15 degrees, which is actually the same as sine of 75 degrees, isn't it? Because of the complementary sort of relationship between sine and cos, isn't it? So that really should be the same as sine of 75 degrees. And it is. Okay. So again, another very, very interesting result. In fact, let's have a look at K and L. We'll do this one quickly. Okay, so sine of 45, cos of 30. Again, this is just practicing the exact ratio. So 1 on root 2 multiplied by root 3 on 2. Okay, this one, so minus sine of 30, so that's half, multiplied by 1 on root 2. It looks like you're going to get something pretty similar before, so like what we had in the previous example. So that's 2 root 2 minus 1 on 2 root 2. Okay, and that's equal to root 3 minus 1 on 2 root 2. Okay, we've seen that one before, haven't we? Cos of 75 degrees. Okay, it's actually the same as sine of 15 degrees. Okay, so if you multiply this by root 2 on root 2, okay, we've done this before, so that's equal to root 6 minus root 2 over 4. Okay, and we know what this one is the exact ratio for. Okay, so that one was for cos 75 sine of 15. Yep, just make sure. So that's the same as cos of 75 degrees. Okay, or sine of 15 degrees. Okay. All right, what about this one? Sine of 45 cos of 30 plus sine of 30 cos of 45. Again, a very, very similar thing. Okay, so this is going to be root 3 over 2 root 2. Okay, same as the top one, minus, it's actually plus 1 on 2 root 2. Again, it's the same as this result here, isn't it? So that's the same as root 6 plus root 2 over 4. Okay, and that's equal to, we know that's equal to cos of 15, which is actually the same as sine of 75 degrees. I just think it's just a cool result. I think it's just something great here to know, sort of, you know, I know it's something that you'll look at later, but again, just working with these exact ratios, you can come up with some very, very interesting results. Okay, there's others as well, but I'm not going to do all of them or make it too exhaustive. Couple more. Okay, tan's been left out of the whole picture, and tan's getting very lonely. So let's involve tan in something. So, right, tan of 45 plus tan of 30 degrees over 1 minus tan 45 tan of 30. Okay, what's going on here? Tan of 45, that's just 1. Tan of 30, that's just 1 over root 3, all over 1 minus. Now, tan of 45 is just 1. Okay, tan of 30 is 1 on root 3. So that's just, again, 1 on root 3. So, but having a sort of fractions inside fractions is not good form. So let's multiply the numerator by root 3 to get rid of this denominator here. And let's multiply the denominator here by root 3 to get rid of this denominator of root 3 there. Okay, so multiplying top and bottom by root 3 on root 3. So every term we're going to multiply it by root 3. So 1 times root 3 is root 3. 1 over root 3 multiplied by root 3 is just 1 over 1 multiplied by root 3 is root 3, minus 1 on root 3 times root 3 is just minus 1. Okay. Now, something here worth noting. I'm not going to rationalize this denominator. I'm just going to leave it as it is. Try this. So compare with tan of 75 degrees. What do you get? So let's try that. Tan of 75 degrees. 3.732 or thereabouts. Okay. And what about this ratio there? So root 3 plus 1 over root 3 minus 1. There you go. So again, not going to prove the point, but this is in fact the ratio for tan of 75 degrees. Okay. And last one, tan of 45 minus tan of 30 over 1 plus tan 45 degrees, tan of 30 degrees. Okay, same deal. I'm just going to, instead of having plus and minus on top, I'm just going to swap them around. So that's just root 3 minus 1 over root 3 plus 1. And guess what that is? Compare with, and if you said tan of 15 degrees, All right, let's see. So tan of 15. Okay, 0.26. Okay, so might on this calculator here, I might just change the. Okay, so make that a plus, make that a minus, and there you go. All right, again, something interesting there. So this is really equal to tan of 15 degrees, and it's the exact ratio for that. Okay, thank you for watching. I hope you enjoyed that, and I hope you've learned something new there, right? And you've sort of discovered that there's really a lot more to this than meets the eye. And I guess a good attitude to have is that when you learn something, okay, hopefully that invokes some curiosity and a little bit more sort of an inquisitive sort of side of you that says, well, hang on a moment, this is great. Is there more to this? And sort of going down sort of the rabbit warren, and thinking, oh, is there more to this? And of course there is, but we're only really just scratching the surface here. Thanks for watching again.